Hello. In this particular lecture, now we are going to focus on numerical on B-spline curve subdivisions. So this part was already covered. First two equations were talking about normal B-spline. Then these equations are talking of the subdivision techniques with insertion of knot. Now let us consider a numerical. For these formulations you can go to earlier videos. So let point B1 has coordinates 0, 0 as xy, B2, 2, and B3 is 4, 2. So we are asked to generate the open second ordered or not second ordered B-spline. So actually there is no second ordered, but for numerical purpose we are considering this. Subdivide the curve not maintain open uniform not vector. So few things we need to note down and need to look at. So first is in the solution, B1, B2 and B3, these are points given with x and y as coordinates. The second thing is it's an open knot and second order, as I've said. It's just for demonstration purpose because the order will be first, degree will be first. Maintain open uniform not vectors. So for open not vectors, the recursive relation is x, let me change, xi is equals to 0 if I is in the interval 1 to k, and xi is I minus k when I is in the interval k plus 1 to n plus 1. Also xi is n minus k plus 2 when in the interval n plus 2 to n plus k plus 1. So we need to understand what are these k's and i's. So for this current given numerical, n plus 1 is 3, that is there are 3 points B1, B2, B3. K is second order, for demonstration purpose we have chosen. So from this first equation, which is of xi, k is 2, so that's why I will be 1 to 2. So x1, x2 is 0 because from the first equation on the top. Similarly, this is for I in between k plus 1, which is in this case 3, and in between n plus 1, which is again 3. So that is x3 will be equals to I minus k, and now the value of I in this case is 3. Similarly k is 2, so x3 comes out to be unit value. Okay, so we need to note this, x1, x2 are 0, x3 is unit value, and for I, which is in between 4 to 5, n plus 2 to n plus k plus 1, that is 4 to 5. So that is for x4, the value will be n minus k plus 2. Now in this case, n is 2 minus k, which is 2, and plus 2, so that gives us 2, and x4 is 2. Similarly x5 will be again 2, same value. So in short, the vector x will be having these values, which are x1, x2, x3, x4 and x5. So they are represented as 0, 0, 1, 2 and 2. Okay, so let us call these as x1, x2, x3, x4 and x5. So we are calling them with prime because we need to modify them. So let us normalize them, so that let normalize by multiplying, let us say by 2. X is equals to twice of this x prime. Intentionally we are doing this, okay, because this comes out to be 0, 2, 2, 4, 4. Okay, so now we can insert two new knots. The first is in between 0 to 2, because we need to make it uniform. So again 3 value in between 2 to 4. Okay, because in the problem it was mentioned to maintain open uniform not vector. So that uniformity means all the values are equidistant. So now y comes out to be 0, 0, 1, 2, 3, 4, 4. So kindly note these: y1, y2, y3, y4, y5, this is y6 and y7. Okay, so these are new important values of y. X is this 5 values. So let us copy them and paste it here, so that these are final values of x and y which we need to use. So let us rearrange this. So okay, x1, x2, x3, x4, x5. Okay, so now these values we need to use. In the formulation we have stated with the new knot vectors, the y is the last value is m plus k plus 1. Okay, so naturally here we have got last value as 7. So naturally this m plus k plus 1 is equals to 7. So in our case, since k is second ordered, m will be equals to 7 minus 2 minus 1. So this comes out to be 4. M is equals to 4. So let us change their style so that these are values which are important and we need to reuse them, because these are our sub answers. So that's why we are highlighting them with different color. Okay, so now once we have obtained, this is an important step actually to get knot vectors. Now vertices we need to obtain for this new knot vectors. Here we need to note, for given m is equals to 4, n is 2, and we have stated somewhere like in our earlier videos that m will be always greater than n, because we have added additional points in the new y knot vector. Okay, so let us go back and we need to use this equation number 5 So let us copy it and paste it. Okay, so now just start by substituting these values. Again we need the range of I and j, so these are equation number 6 and 7. So copy and paste. Okay, so here we need to understand I is in between 1 to n. Now in our case that is 2. Similarly j is in between 1 to 4 because it is of m. Okay, so these are values of I and j, so we need to substitute them in equation 5 and we need to rearrange it. So we get for j is equals to, let us say 1, c1 is equals to summation of I 1 to n plus 1, that is 3, and alpha I comma j, which is 1 now, and 2, k is 2, and pi. So that is the value of c1. So if we expand, so we need to note here that let us call this equation as 12th, 13th, these not vectors we need them, 14, 15, this value of m 16, okay, and this equation is 17. So now c1 will be equals to, so alpha I 1 1 to b1 plus alpha 2 comma 1 b2 plus alpha 3 comma 1 b3. So let us call this as equation 18. Now similarly for j is equals to 2, this equation c2 will be alpha 1 comma 2 comma 2 second ordered b1 plus 2 comma 2 b2 plus 3 comma 2 b3, equation 19. Similarly for j is equals to 3, c3 will be alpha 1 comma 3 second ordered b1 plus 2 comma 3 b3 plus alpha 3 comma 3 b2 3 comma 3 b3. So these alphas are basically weighting functions, you can observe them, they are giving weights to b1 b2 b3. So let us for c4 will be equals to alpha 1 comma 4 b1 2 comma 4 b2 and 3 comma 4 b3. Okay, let us call this as 21. So we have reached to 4th level. There is one more level required, which is for j is equals to 5, because the polynomial equation needs it. So j is equals to 5, c5 is equals to 1 comma 5 b1 2 comma 5 b2 plus 3 comma 5 b3. Let us call this as 22. So now we need to obtain these alphas. Remember they are of second ordered, so their values we need to obtain. Okay, so how to get them? b1 b2 b3 are vertices, that information is with us, already given, defined in problem, but we don't have these alphas. So first of all we need to get